Hi, this is Chris Thron. I teach math at Texas A&M University, Central Texas, and this is part 2 of my talk, Student Mathematical Modeling Projects with Interactive Excel Spreadsheets. Let me briefly go over the overview that I went over in part 1 of this. I had 2 students enroll in the projects class, Kara Klinke, Danny Salinas. In this presentation, I'm going to do Danny's presentation that has close relation with actuarial work. The motivation for this project was to address a meaningful practical problem related to the student's chosen profession, to show that math modeling can enhance practical policy decisions, and to come up with a useful product that others could potentially use. So the question, why use Excel? I spoke about this thoroughly in the first part of this presentation. It leverages prior knowledge. It's universal on-the-job software. Wherever you work, it's going to be there. It's useful to know Excel. The interface is already there, built into Excel, and although it's not as portable as Java, on the whole, we felt the pluses outweighed the minuses. So let me go right to Danny's presentation, which is entitled How Much to Fix My Car? Estimating Repair Costs. And the motivation for this project was the question, should I buy a new car or keep my old clunker? In order to make a good decision, it would be helpful to know what repairs would cost if I do keep the car. So we've developed an Excel spreadsheet program that uses a reliability model to estimate my repair costs over the next year, which will help me decide whether I'm going to keep it or invest in a new one. We tested the methodology on the Toyota Camry, best-selling car in America for 12 of the last 13 years. We did so because we could obtain the best data for this model. Okay, so our prediction methodology, we used actual data obtained from this site. This site is a site where users can log in and record their repair history. So we extracted the data for Toyota Camry. To get repair cost data, we looked at these 3 sites. And our reliability model, of course, there are assumptions in the model. Our assumptions were that the times that different types of repairs occur are independent. The probability density for each repair time is a step function. There's a certain time t0 for each repair before which no repairs occur, and then repairs are equal probable on equal time intervals thereafter. Now, of course, this is a huge oversimplification, but it is a first step in a model, and it was really all we could do with the data that we had. So the model parameters were computed based on the true delta data using MATLAB and exported to Excel. So the user product is Excel, but a lot of preliminary work was done which required MATLAB. Okay, so here's the actual sheet. The light colored cells are the ones where the user can input. The darker colored cells are locked. So what the user can do is input their current mileage for their vehicle. Let's say that I have 100K on my vehicle, and I plan to put another 35K on it this year. So the final mileage will be 135. Cost estimate. Well, depending on where you live in the country, you may have low, middle, or high repair costs. Let's suppose I live in a high repair cost area. So you can see that what it spit out is the expected number of repairs, standard deviation of number of repairs, expected total cost of repairs, and standard deviation of the repair cost. So what we can see is that we expect to have 3.7 repairs. The expected total cost of all repairs is over $1,000, and the standard deviation is 8. So it seems quite likely I'm going to have to spend at least $500 on my car. But there's more features to the spreadsheet. I can include my repair history. So for instance, I replaced my timing belt at 90K and my water pump, so I'm going to go ahead and put that in here. So let's see, where's the timing belt? Let's find timing. Okay, let's see, let's find it again. Here. So I replaced this at 90K, so I'm going to put that in. And I also replaced my water pump. I replaced that at 90K. Well, let's go back up and see. You can see that my expected cost of repairs has gone down somewhat because of the repairs that I've done. Now, the spreadsheet also breaks things out graphically. Here's my electrical expenses. So you can see that alternator replacement is the most expensive repair in terms of expected value. You may or may not have to replace the alternator, but that's likely to be a large repair. Expected engine expenses, radiator replaced, expect to spend $70 on that. Of course, you'll either repair it or you won't, but the mean expense is $70. We also have different repair probabilities. For instance, if I want maintenance probabilities, quite likely with probability 0.18, you'll have to replace an interior door handle based on the data that we had. Now, of course, we had a fairly small amount of data to work with, but the methodology is fundamentally sound. With a larger data set, we could come up with better predictions. Well, we wanted to do something to verify our methodology. So what we did was we used the Corolla data and predictions, we used the Camry data and predictions based on the Camry data and applied it to another data set of Corolla repairs. And the way we did that was we plugged in the repair history for each Corolla recorded in the data set, and we got an expected repair cost and a standard deviation for repair cost, and we computed the z-score for the actual repair cost that Corolla experienced. We plotted the z-scores that we obtained here on the blue bars. That's this histogram. Now, of course, if the Corolla data really did follow the model, we would get a normal distribution, which is the red bars. And you can see that the blue bars do deviate from the red bars. The mean is pretty good. And if you actually compute the mean, it's really very, very close. However, the spread is quite different. And what this means basically is that our model is faulty. Repairs really are correlated. So if we had time, we would go back and improve the model. But at least we have a first-pass model that has some degree of accuracy in predicting repairs. Okay, that's it for Danny's presentation. This PowerPoint and the original student presentations are available at my website, which is listed there. And for further inquiries about the spreadsheets, if you'd like to get a hold of them, please email me at the address below. Thanks for listening. Hope you enjoy.